Hello and welcome to the homework helper for section 711. Let's get our Slurpee on. All right, first section is we're going to be converting measurements of area and then area and perimeter. While working with areas is something essential to converting between units of measurement, for example, changing from square yards to square feet and so forth. So pretty much what we're going to have to do is we're going to have to figure out how to convert these to the different measurements. So when we're looking at yards, if we have 7 square yards, we have to figure out how many feet are in a square yard. And in fact, the number of feet in a square yard, well, let's think about it. In a yard, right, a yard is 3 feet. So each yard is going to be 3 squared feet, so it's going to be 9. So we have to do 7 times 9 to figure out the number of squared feet in our yard. So for all of these, make sure you're doing that. Like think about how many are in each. How many inches are in a square foot? Multiply it by 5. How many square feet are in a square mile? Multiply it by 1. Well, that's easy. But et cetera, we'll go from there. All right. The next section is transformations and parabolas, symmetry and parabolas. So we're going to graph each of the quadratic functions. F of x is x squared. This is going to be our parent graph. So x squared, 2 is 4, 3 is 9, and then it reflects. And that is our f of x. F of x. Okay. Then we're going to do x squared minus 9. So it's going to be the same thing, except my vertex is going to change. It's not going to change anywhere on the x, but it's going to go down 9 on my y. So I'm going to go down 9. And then I'll just mimic my parent graph. Go over 1, 2, 1, 2, 3, 4. When I go over 3, I go up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. When I go over 4, I go up 16. So that was 9, 10, 11, 12, 13, 14, 15, 16. All right, and then I mirror it. I mirror, and I mirror. There we go. So that looks something like this. That is my h of x. And then finally, that was my g of x, not my h of x. G of x. I was looking ahead. And then my h of x is now I got to change my x. I'm going to the left 2, 9. And then I follow the pattern. Up to here. And you can see I'm just 2 over from my g of x, my red line, so that makes it a little bit easier. Just 2 over, 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 and just 2 over. Beautiful, easy. All right, so this one's going to look something like this, h of x, Reno. Okay. Now you get to compare how they look from each other. How do they compare to each other? They're both parent graphs. You know, it says talk about how g of x and h of x compare to f of x. F of x is our parent graph. You know, g of x is moved down 9 units. H of x is both moved down 9 and to the left 2, etc., etc. And so just go through these questions and mark down your observations on how all of these fit together. All right. And then finally, our final section is function notation and evaluating. So it starts off by asking us, okay, if f of x is all of this, if f of 0 is this, what do we do? So when it says f of 0, that means our x is now 0. So let's evaluate our function as though x were 0. So f of 0 would be 0 squared plus 4 times 0 minus 12. Well, this is just zeroing it out and finding our intercept, right? This is 0 plus 0 minus 12, which is minus 12. Minus 12. Let's do it for 2 now. F of 2 is going to be 2 squared plus 4 times 2 minus 12. That's going to be 4 plus 8 minus 12. That's going to be 12 minus 12. That's going to be 0. Okay. Now, this one's actually kind of fun. It asks us when f of x equals 0. So when our y value is 0. So when 0 equals x squared plus 4x minus 12. Now, when we're looking to find our zeros, the easiest way to find our zeros was factored form, if that works. Otherwise, we need to do vertex form and solve. Looking at this, it appears that we can factor this, right? We can do what two numbers multiply to negative 12 but add to 4. That's going to be negative 6 and a positive 2. So 0 is x minus 6, x plus 2. So what values would cause this to be 0? This would have to be 0 equals x minus 6, or 6 equals x. That's 1. This would have to be 0 equals x plus 2. If I subtract 2, negative 2 equals x. That's the other. So my values for x are going to be negative 2 and 6, because those would cause these to be 0 and 0 everything out. So now it gets a little bit more complicated, because this is asking us for when f of x equals 20. But luckily, we can do that still. Okay, we'll set it up the same way. 20 equals x minus 6, x plus 2. Not quite the same thing, right? We're having to do it a little bit differently. Well, let me see. What is something we can do to make this work? Well, I think we're going to have to put this into vertex form first. Vertex form. So to get this into vertex form, let's go back to the original. X squared plus 4x minus 12. F of x equals all this. Ignore the 12 briefly. Complete the square. F of x equals x squared plus 4x. And when we complete the square, we take our b over 2 and square it. So 4 over 2 squared is 2 squared, so plus 4. But if I add that 4, I have to also subtract the 4 to keep it balanced. All right, now from this trinomial, I can write a perfect square. That's going to be x plus 2 squared. Combine my terms, minus 16. Now I can set this equal to 20. I will add 16, giving me 36 equals x plus 2 squared. Okay, I'm going to write this on a second sticky note. So now I need to take the square root of 36 equals x plus 2. If I square root both sides, the square root of 36 is either 6 or negative 6, right? Because 6 squared is 36, negative 6 squared is 36. So 6 equals x plus 2, or negative 6 equals x plus 2. So 4 equals x, or negative 8 equals x. So those are the values that will give us 20, either negative 8 or 4. Cool. So that's going to be our process. Let me do one more with you guys, just because it's a little complicated. Let's see how it works. This one's already given to us in vertex form, so this may make it a little bit easier. We're going to start by just finding when x is 0. So g of 0 is going to be 0 minus 5 squared plus 2, minus 5 squared plus 2. Minus 5 squared is 25, plus 2, 27. 27. Let's do it for 5. G of 5. 5 minus 5 squared plus 2. 0 squared plus 2. 2. 2. Sweet. Let's set it equal to 0 now. So 0 equals x minus 5 squared plus 2. Subtract 2 from both sides. Negative 2 equals x minus 5 squared. Square root both sides. Ooh, look at this. Square root of negative 2 equals x minus 5. Is there a square root of negative 2? There isn't. because no number times itself can be negative. So if no number times itself can be negative, where do we have g of x equals 0? There is no answer. Neat. That's so neat. Okay. Now, full disclosure, this does lead to something called imaginary numbers, which we won't get into in this course. Let's see if we can do it for 16. Let's see if there's a value for 16 that works. So 16 equals x minus 5 squared plus 2. 14 equals x minus 5 squared. Square root of 14 equals x minus 5. Now there's no nice and neat number that's the square root of 14, so we'll just call this plus and minus the square root of 14. We're not going to round it off into a long decimal. Let's add 5, so 5 plus or minus the square root of 14 is x. So our answers are 5 minus the square root of 14 and 5 plus the square root of 14. And we can estimate how much the square root of 14 is, right? We know the square root of 9 is 3, and we know the square root of 16 is 4. So it's between 3 and 4, possibly closer to 4 than 3. All right, team. That's what we need to do for these. Remember, if you end up with the square root of a negative number, like so, that means we're going to have no answer, because we can't take the square root of a negative number, because no number times itself will become a negative number. All right, thank you guys so much, and good luck on your homework.